Hello everyone, welcome back. So we created NumPy arrays, and what we're going to do now is we're going to plot them. The first thing I'm going to do is I'm going to create a box plot of the one-dimensional array. So it's very straightforward. I don't need Seaborn in this case. I could use Seaborn, but I will have to convert my data into a data frame and do a few things like that. And you may want to do that depending on your application, depending on your use case. Here, I just want to plot to a simple box plot of my one-dimensional array, the one I just created in the previous video. So all I do is just call box plot. Let me get a pencil here. Here we go. So call the box plot method of matplotlib, and then I'm going to add title and labels to my X and Y axis. That's it. That's straightforward. So let's do it. Let's run this code. Again, you have to have the instantiated array before you do this. So here we go. And there it is. So it's pretty uniform. As you recall, the 1D array, let's see, I did the new 1D array. If we go back to the 1D array, it was a random set of numbers between 50 and 100, and I got 20 of them. So since it is random, the distribution is going to be pretty uniform. So it's going to be a pretty nice distribution. We're careful when I say the type of distribution. We haven't gotten into statistics yet, so we will have to look at the random rand init function with more detail, because it's giving you a distribution which is actually a bell-shaped type of distribution. But you know, it's going to get numbers between, what did I say, between 50 and 100, and I'm going to get 20 of them. And when I plot it, I'm going back to my plot right here. It's a box plot. You can see that it's somewhere between the 50-ish and the 100, the min and the max, and the median is it's going to be around 50. It's going to be around 50. They're randomly selected, so I cannot say it is 50. If I use the line space, I could be more precise and tell you how this is distributed, but it was random. And so here's my 25 percentile, 50th percentile, and 75 percentile. So they fall where I would expect it. So it gives you a quick box plot. Let's do another kind of plot. All right, so you see the box plot, and I can box plot with an array by just simply, and the whole point of this video here is to show you how all I need to do is just to pass the NP array, the NumPy, I'm going to write it like this, array. I'm going to pass it to this method, and that method is the box plot method on matplotlib. All right, so I just pass it to the method, and the method belongs in matplotlib, and that's all I need to plot it. All right, so let's do this. Let's now do another kind of plot. This time we're going to do a bar plot. Now, so the bar plot's a little bit different. So what I'm intending to do is I got my numbers, and each number is going to be a bar. You know, the height of the bar is going to be the value of the number. That's what I want to do. But a bar plot is categorical, which is it's not like a scatter plot, meaning the y-axis is basically a category. And the category that I'm going to give to this bar plot is going to be the position of the number. So if it's a low number, the position is going to be low. If it's a high number, it's going to be high. So you're going to see it as soon as I plot it. But the point first is, if I want to do a bar plot, I have to get my positions, because I'm going to pass those positions as an argument into my bar method. So this time I'm not using the box plot that I did above. I'm going to use the bar method of matplot of my library, matplotlib. And what I'm going to do is I'm going to pass two X and Y. I'm going to pass two variables, two arguments, and those arguments are x and y. The position is x, and my y is the value that I get in the array. So let's see what it looks like. The last thing I did is just give it a title and labels, and then do the plot. Tell it, go and do this, go and plot it. So let's run it. There you go. So the position, it starts at 0. Sorry, let me get a pencil so it doesn't move like that. Starts at 0 and ends a little bit under 20 here. Those are the positions. But the point of the matter is that each position has a value, and the values are like this. It's kind of like trying to, if I give more numbers, you probably will start seeing like a bell shape. That's what I was saying a little bit earlier when I was describing the box plot. And you can actually see it here a little bit. It's not, because it's only 20 numbers. We will have to do this the random call from before with, say, 200 numbers. So it will look a little bit different. But this is not a statistical, it's just an introduction video. Is just to show you how I can plot NumPy arrays, right? And then the last one that I'm going to plot for you, which is now also very interesting, is the 2D array. Now for the 2D array, we need a little trick before we pass the argument to the box plot. I'm going to do a box plot in this case. So I'm going to do a box plot, but the box plot wants to see it like this: the header and then the values, the header and then the values. And the way I have it right now is I have my NumPy array and then the values, and the NumPy, and then I have them horizontally. It's hard to describe because these are numbers. This is what the computer sees, but that's one way to think about. So I need to do a transpose, bottom line, and the transpose is with a .t method that can be used on my array. So I just do a .t, and it's going to do the transpose. So I'm going to transpose to go from something that looks like this to something that looks like that. That's all. Same values, same numbers, nothing changes. And then that transposed array, I'm going to pass into my box plot. So just let me use my cursor here. That transposed array, I'm going to pass to my box plot. Here you go. So now I have my two box plots. So now remember, I created a little in the previous video, I created two random arrays. I created a two-dimensional NumPy array, which means each one has, say, two arrays in it. It's two-dimensional, two arrays in the dimension of my NumPy array. And the first one was between 50 and 100. So it's this one, that's the first one. And the second one has random numbers between 10 and 200. So it's this one, right? That's the first one, and this is the second one. So when you plot it in a box plot, that's what it's going to look like, right? That's what it's going to look like. So it means your median for the first one is around here, around 75. For the second one is around here, a little bit like 105, something like that. For these random numbers, and the percentiles fall in this and this for each, and then the maximum and the minimum are depicted by the whiskers. That's the maximum and the minimum in my data. So, but the bottom line is, right, because we cover box plots in a different video just before this one, and here I'm showing you how you can use the NumPy array or arrays to create box plots using Matplotlib. So let's see what I was going to show you here before we go. Yeah. How we created the random numbers right here. So in this one, in the 2D array, so just to recap the last box plot, the first one is between 50 and 100, and the second one is between 10 and 200. You see? And so when I did the box plot, go back to the box plot of that to the array, you can see right there. Okay, that's where it comes from. It's the one that is between 50 and 100, randomly picked, and the other one that is between 10 and 200 randomly picked. All right, so this is the last video of instruction for CEIS 110. I'll just do a summary video coming up. Remember to follow me on GitHub. All of the code is on GitHub. So if you go to the GitHub, and you'll see it on the list, you go to the GitHub and go to, there's project and there's modules. If you go to modules, you will see all of the Jupyter notebooks here and some Python files as well. Like the last one that we just created is going to be here once I update my GitHub. But you can go back here. For instance, the pandas intro is right here. So you can see all of the code. Scroll down. You can see all of the code that I did during my videos. Right? See, you can download to your desktops and test them, or you can also clone my GitHub and you'll always be up to date. And that's it. That's it for now. Then I'll talk to you later. All right? Take care. Bye-bye.